Alright, so I'm going to make a short video here illustrating the technique we discussed in class today, Monte Carlo simulation. So just real quick to review the general idea. We're going to generate a list of random numbers between 0 and 1. So we're going to get a list of 100 numbers, and each one will be a number between 0 and 1. And the idea with Monte Carlo simulation is we can interpret these numbers as percentiles in a standard normal distribution and use the inverse normal CDF to create random samples from a normal distribution. And this is a very powerful technique that comes up in all sorts of places. So I'm going to show you how to do it on your calculator here. Good first step always is to make sure your lists are clear. So if you go to second mem, clear all lists. All right, let's clear that. So the idea here is we're going to go to the stat editor into the list editor. And we're going to pick the first one here and go into the formula bar. And we're going to use the sequence editor to create a sequence of random numbers. And remember that's under second list. Go to ops and then number 5. And actually I already have it typed in here. So the expression here, rand, just remember where you can get that at. Let me clear it and enter it in again. So you hit math and go over to probability, and the very first one is the rand function. Then the variable, here it's going to be x. It's just always going to be x, even though our expression doesn't involve any x. It's just a constant. Well, it's not constant because it's generating new random numbers each time, but it's an expression that doesn't involve x. So we're going to start at 1 and go up to 100 in steps of 1. That will give us 100 random numbers. Then we're going to paste this into the formula bar and give it a second to do its thing. And notice we have now a list of random integers, or not integers, sorry. We have a list of random numbers between 0 and 1. So just real quick, notice in the formula bar here, you can see my taps. See how it says L1 parentheses 7 parentheses? So this is actually, you can use this in the main menu. So if I type parentheses 7, you can access specific elements in a list. So when I execute this, I get back whatever number occupies the 7th position in this list. So this will be useful here in a second, so just keep that in the back of your mind. Now let's actually turn on our stat plot and take a look at what this distribution of random numbers looks like. So turn on your first one, make sure the histogram selected, and you have the appropriate list inputted into your data. So if you now hit graph, you might have to zoom stat to get a good window, but it looks like I have one already inputted. So look, notice we get an approximately uniform distribution. If we generated more random numbers, we would get a better approximation to a uniform distribution. That would be the law of large numbers in action right there. But the idea here is we're going to use this distribution of random numbers to create a new distribution a new distribution that represents observations made from a standard normal distribution. The way we're going to do that is we're going to go back to the sequence editor. So first of all, we're going to highlight the formula for L2, and we're going to go back to the sequence editor. And here is the tricky part. So it's going to be over the same like start and end and step. So we're going to start at 1, go up to hundreds. But what we're going to do here is we're going to use this new function we've introduced in class, the inverse norm. And remember, this accepts percentiles and gives you back z-scores. And what we're going to do is that trick we were just showing you. We're going to type in second L1. We're going to access an element in the list. And what we're going to do is we're going to iterate over the list. We're going to pass in the x expression, or the x variable into this expression. So what this is going to do is it's going to step through 1 through 100 and grab each element of the first list and then input it into the inverse norm. So let's see what happens. Whoops. All right, yeah, let's see what happens here. Okay, so now we have a list, and if you look at this, these represent z-scores. These are random z-scores. So now, if we go to the stat plot, and instead of plotting L1, we plot this new distribution that we've created. And for this one, we do have to hit zoom stat to get a good window. Notice it's approximately normal. So think about what we've done here. We've created a list that represents a uniform distribution, and we've interpreted the values as percentiles. And then we've inverted the percentiles into z-scores. So this is how